Before using any machine in the shop, you should read and understand the owner's manuals. This machine here is our drill press. Now you'll notice that the table is beveled at this time, and just like some of our other machines, this can angle or tilt so that we can actually drill holes at different angles. So to change or adjust this, or to even see where it's at, if we take a look right back here, so back by the post here, we'll see an indicator that tells us what degree that the table is set at. So right now, looking at this indicator, we're about 20 degrees angle on the table. So to change this back, we're going to view this dial as we lock it into place. And we have to go underneath the machine to make these next adjustments. So let's go take a look underneath. So underneath the machine here, there is this locking handle that we just need to release. And once we untighten that, that will allow the table to be positioned to whatever angle you want. Once you get it where you need, then you're going to come back underneath and tighten up this handle and secure it to the size that you want. Before we tighten it too much though, we're going to take a look at the tabletop and make sure that we are 90 degrees. So back up here on top, we're going to use a speed square and a longer bit here to determine if we're square or the table is back to a true 0 or 90 degree angle. So if we slightly move that around and we use our speed square against the blade, we should be able to see that gap in there and know when we get it just to the right spot. So you're going to fine tune it. Once you get it where you want it, then we're also going to go back underneath and lock it how we did before. So now that we've got the bit and the table nice and square to each other, we're going to come back underneath. We can use the locking lever to hold this in place. And while this is held in place, we're going to get the 15/16 socket and we're going to tighten up this bolt here. And this bolt is going to keep the table from moving with any pressure. So don't trust this locking handle. We really need to get a bolt or a socket on that bolt to get it secure. Like our many other machines, we don't want to assume that this is set up for what we need. We, as the operator, want to make sure that the parameters are all set for our operation. So you'll need to check the table height, the bit size, the bit speed, and so forth to make sure that it's set to the right parameters for your job. Don't assume that little Billy, who used it before you, set it up correctly. All right, let's talk about this materials that we might have on the drill press. And so if we have a long board like this, there's a couple ways we could cut this or drill it. One, we could have our spare material off to the right side of the table. And that is one option, and we would put our clamp over here to hold it down. The other option is to have our excess material over here to the left side. So those are two choices, and one of them is a better choice than the other. And that's going to be with the material off to the left side. So if this were to get pinched on the blade or bind that bit, and it kind of come loose from our clamp, then as this is spinning around, it's going to hit this back post back here before it can spin around and hit us. If our excess is over here and it were to get caught on the blade or bit and our clamp come loose, it's going to spin around and hit the operator before it hits that post and stops spinning. So if you have a choice, you do have a choice, put your long or extra material off to the left side. So if it's off to the left side but your hole needs to be down there, then just turn your board around and that should get you where you need to be. You'll notice these tracks or grooves in the tabletop. Those are going to be tracks for holding down, for clamps that will fit in there, and for our auxiliary fence to fit on there. It slides into those grooves, and then you can position that where you want. If you're drilling multiple holes at the same distance or the same size, then you could maybe use that fence for some support. This is also a good reference for our fingers. Our hands, when holding down the workpiece, should not be over these tracks. If they're over the two tracks, your hands are too close. We're going to change the bit out, and before we do that, we want to make sure it's unplugged from the power source. Our hands are going to be closer than 4 inches to the cutting surface, and so we want to make sure the power is disconnected. We're going to take one hand on this lower kind of black ring here. It's textured so you can grip it. And the other hand is going to go on top on this upper ring. And we're just going to take your two hands and twist and loosen that up, and the bit should slide out. If you will grab the bit so it doesn't hit the ground or hit the metal table, that way we don't damage any bits or blades. So when we're putting in the new bit, we would just take that, hold it with our fingers, and operate the bottom ring around there, and use that ring. If you go the wrong way, it's going to get bigger, and use that ring to secure it in place. And tighten it up when you get it there. Now, if you spin it by hand, you should be able to tell if it's straight by looking at the position there of the bit. When we turn it on, we'll do a test run to make sure it's straight before we start our cut. So if we turn the machine on and look at the bit's rotation, we can tell if the bit is installed correctly straight in the chuck. So if we turn it on and it looks like it's wobbling quite a bit, then it's not in there correctly. Let's take a look. You'll notice on the bottom side how big of rotation it looks like it's making. So that bit is definitely not in there straight or seated in the chuck correctly. All right, so that bit was not in there straight. We need to change it and correct the seating in the chuck. First thing we're going to do is unplug the machine from the power source. We're going to be touching the bit. We don't want to get our hands caught in there. Put that somewhere you can see it. You could always stick it in your pocket if you wanted to make sure nobody accidentally plugs it in on you. So then we would loosen the chuck and get the bit out, and make sure those little jaws under there all feel like they're kind of centered and close to the size you need. Then you can get it installed and just slowly keep it centered in the chuck and then tighten it up. Then we can reinstall the power or replug it in and see if the orientation or the alignment is good this time. So now we're going to come back and check the bit and make sure that it's spinning good. Looks like we've got it installed correctly. When we go to operate the drill press, we're going to use this handle on the side to pull or rotate the spindle down. So this handle is what guides our cut, or how far in our cut will go. All right, so this is what we hold on to while we're operating. Our other hand is going to be on the workpiece to make sure that it doesn't move while we're cutting. So we're going to take a look at this scrap piece here. We're going to drill a hole in here. So the first thing we want to do is make sure that our drill is going to be able to come all the way through the workpiece. If it's not, or if it's too close, you might have the table up really tight for a 1/4 inch piece of wood, or maybe you got a bigger piece and the table's down low. You'll need to adjust the table height. And let's take a look on how you would do that. We've come around here to the back side of the machine, and we have two levers or handles. This one here is what's going to raise and lower it, and this one right here is what locks it in place. So if we loosen the locking handle, we're going to take this handle and crank on it, and the table should move up or down depending on your rotation. So you're going to get it lined up. You want to make sure when you're close that your workpiece can fit underneath the bit and that it's not going to scratch or scrape it as you line it up. The other thing we want to do before we tighten down that back locking lever is make sure that the bit is into this sacrificial piece. We wouldn't want this table to be tilted or turned so that the bit would hit the tabletop. So we want to make sure that that is straight to the point where if our bit goes through our workpiece, it's hitting this scrap piece of wood that can be replaced. So go ahead and tighten that back up. You got it in place. Tighten the handle back up. It doesn't have to be Superman tight, just snug so that it doesn't move while we're spinning or while we're operating. Before we use this, the operator's responsibility is to check the cord and make sure it's in good condition, make sure the prongs are all there that need to be, and that they're all look in good condition, that none of them are loose or completely missing. If some of them are bent, maybe it was on the floor and it was bent a little bit, you can take your fingers and just kind of push them back together as long as they are not loose in the hole that they fit in. Then we're going to take our hand down the cord and visually inspect the cord, make sure there's no breaks in the outside protective case of the wire, make sure it all looks good and no bad spots in the wire. Then you can go ahead and plug the machine in. When you're drilling a hole, we should have a marking on our board of where that needs to be. So I've measured over a certain distance this way, and that's where that vertical line is. And I've measured a certain distance down, and that's where that horizontal line is. So that X is going to give me a nice indicator of right where the center of the bit should be. So then what I'm going to do is take the tip of the bit, and we'll just use this one for example. We're going to take a tip of a bit, and we should be able to line it up right in that center of that X while you're getting it lined up on the machine. That way you can tell perfectly where your hole needs to be. So let's get this lined up on our machine. So I'm down here close to my workpiece. I've got my bit here, my little marking here, and we're trying to get that center of that bit right on the center of our X here, or our crosshair. So I'm going to line that up, and while I'm lining it up, I'm going to pull on the handle of the machine and slowly bring it down. I don't want to jam it into my workpiece because I don't want to damage the wood. And I'm going to line that up so that I am exactly center in that crosshair. Now we need to secure our workpiece down. We could use our hand, but we want to make sure that we're clamping it down to the workpiece. We don't want any accident to happen because this workpiece is vibrated loose or something were to slip. So we should take a clamp, and the wooden twist clamp works best in my opinion for this application. And we'll tighten this up to the table. We want these jaws to be over the center of the table as much as possible. If they're way out here on the end, when we clamp it, it could lift up our workpiece and cause a gap underneath. So we're going to get our piece lined up and those jaws in over the table as much as possible and tighten that up. Now when I drill, okay, I'm going to use my left hand on the workpiece as well as the clamp, and this will just let me feel if the workpiece moves at all while we're drilling. That just lets me know if my hole was really where I wanted it to be or not. So we've plugged in our machine. We've got a display up here that will display our RPMs. We have a couple functions here. We have a little laser centering light that should show us roughly where the center of our bit is. I would not count on that to be accurate in this shop. We've got students in here using things, and things get bumped and messed around with. So I would not trust that that X is in the center of our bit. So the laser is a nice option, but we're probably not going to use it. There's also a little light, a work light, that you could turn on to illuminate your project a little bit better if you need to be able to see. Maybe it's a little bit darker location, maybe you've got a real faint line that you need to see better. So we see this RPM display, and what that does is when we pull out on the knob here, we're going to pull out to turn it on, it's going to display our speed. So right now we're at about 1,053 RPM, 1,050 RPM. When we turn it off, it's going to go back down to 0, so because it's not running, there's no spinning at the moment. To change our RPM or speed, we're going to turn the machine on. We can see what it's set at, and then we can come over here to the left side of the machine, and there's this little handle. This handle, depending on how you turn it, is going to increase the speed or lower the speed. So if we bring this handle up to the higher speed, we can see as I'm turning that we're slowly getting faster and faster. Okay, so if I want to lower that back down, we can lower that speed back down and get that where it should be. When we're talking about our speeds for drilling materials, you need to know that not all materials get drilled at the same speed. Okay, things like metal or hard materials are going to need to be drilled slower than something soft like wood or plastic. So depending on the type of material you're cutting, that's what's going to determine your speed. Another factor in determining your speed is the size of the bit. If you're using a large bit like one of our Forstner bits, that's going to require a lower speed than something smaller like one of our Brad Point fluted bits. So just note that the size of the bit also affects the speed. And the best way to know which speed you should be running at is to refer to the owner's manual. The owner's manual can be found on my website, and that will have a link to this machine, and you can look up and identify based on the type of material you're using and the size of bit what speed you should be operating at. Before we turn the machine on, we should read and understand the warning labels that's over here on the left side of the machine, and read those to get in the right frame of mind before using this machine. All right, we got everything set up. Let's go ahead and turn the machine on and drill a hole. So I'm going to pull out on this red knob, turn it on. I'm going to hold on to my workpiece, and I'm going to use the left hand over on this handle. And I'm just going to slowly bring that down and let it engage the wood. Okay, if you're drilling into thick material, you may have to stop and clean out the flutes of the blade or the bit so that it doesn't overheat. The more times you back out like this, the better you are going to keep that bit cool and at a better operating temperature. We can see by turning this machine off that there is some buildup in the flutes. So if we take a look, the flute here has some buildup in there, and that's what's going to cause overheating because of the excess friction. So if we clean out this, when we go back into that hole, it's going to push all that dust out of that flute. So let's continue on through the workpiece. Okay, when you get to the end of the hole, you should feel a little breakthrough. Okay, you should be able to tell when you've gotten to the end of your good material, and now we're into that supportive block underneath. So let's take a look at this board and see how we did. When we're cleaning off our sawdust, we should be using a hand broom or air. You could use your mouth to blow on it and clean off all that sawdust. So let's take a look here. We've got our hole. The top side looks good. We were pretty close to center. We probably were right on. My pencil marks are probably just a little longer there on one side than the other. And let's take a look at the back side of the hole. So this is the back side, and what happens when we're drilling is this last little section gets really thin. And so as we're pulling the machine down, there's a lot of pressure here. And so when this is really thin, it tends to just push through rather than cut. And so if this was a good piece we need to see on both sides, we now have got this defect that we got to deal with. So one way to combat that I have seen people refer to is to put a piece of tape over the area you're going to drill. And that way when you break through, that tape is supporting the hole. So let's try that. Let's take a piece of tape and see how well it helps our workpiece. So with the tape method, we're going to just use some of this blue painter's tape and press that on there. And I'm just going to kind of overlap it just so that we have it covered in the area that we're going to be drilling. Because this is just a test piece, we are not going to have our crosshairs like we did for the first hole. So let's line this up over in the taped area. We're going to get our clamp in place. Now, if your workpiece is hanging off the table and your jaws are towards the end, then you can come up to the front side so that your jaws can be over the workpiece more. Okay, if the workpiece is sticking way out here and your jaws won't reach, then come to the front of the workpiece and clamp that down. That will allow those jaws to reach in there further. So we're going to clamp it in place. We want to make sure it's nice and flat after we're done clamping, that we haven't lifted the board off the table. So let's go ahead and drill this out. Again, with that sawdust, we need to use the hand broom, or we could blow on it to get that dust off there. We should not be using our bare hands to wipe any materials off of the table, because we could get slivers, especially, or cuts, especially if we're dealing with metal. So let's see how that tape held up. So we can see here that we still have kind of a blowout through that tape. Let's peel this off and see how we did. So this has been my experience with the tape method, is that I still end up with chips that I don't want to have. And if you look at the two holes, they're pretty much identical in the amount of blowout that they have at the bottom side. So this time, we're going to use a scrap piece of wood underneath our good piece. So we're going to take our piece here, we've got our two holes that have blown out, and we're going to put that down on the workpiece on our scrap piece. We're going to clamp both of these down, and we're going to see if this scrap piece underneath will help keep us from blowing out the bottom. So again, we're going to clamp our workpieces down to the table and secure them. Then we're going to turn it on and drill our holes. Take care of that dust, and let's check the bottom of our hole. So this hole has a lot less defects on it, or blowout, because it had that scrap piece underneath. So this is going to be the better way to protect our material if we want it to be nice on both sides. Again, remembering that most of that blowout comes because as we're breaking through the material, it gets really thin, and we're actually not cutting it, but we're just pushing it out the backside. So that was a better option for our holes to be no blowout. So there's our first one there that's got the blowout. Actually, that was the one with the tape, actually. This was our first one down here, and then our good one that had the backer board. All right, there might be a time when you need to drill a hole and only have that hole be so deep. So for example, maybe you need to drill multiple holes, and we only want that hole to go halfway through the board. So we have this little indicator or depth stop over here on the side. We can turn that like a traditional screw or bolt. There's also a little thumb indicator there. You can push in and slide it a little bit faster to the size you want. That way, when we turn the handle, it's going to hit that stop and not allow us to go deeper than we want to go. So if you're drilling multiple holes that all need to be the same depth, then you could set this, run a test piece and set it to the accurate size that you need, so every hole would be the same depth. Or maybe you're just using it on one hole that needs to be a certain depth so it doesn't come through the front side. One particular thing that we'll be drilling in here is the blank for the pen project. You'll be turning a pen on the wood lathe, and so we have little blocks like this that will need to have a hole drilled in them. So let's get this machine set up for that at this time. We're going to use our jig here that's going to secure our workpiece upright. So we're going to open this jig up, or clamp here, and we're going to load our piece in here corner to corner. That will keep it as vertical as possible. If we load it this way, there's no telling what angle we have it loaded at. So we want to use these notches and load it corner to corner. And we're going to secure that in there. Now, obviously our table is way too tall for what we're doing, so that's where we come over to the left side, undo this locking lever. Then we can go over to the right side and raise and lower the table. Okay, now we don't want to be too high above the workpiece because the machine has about a 6-inch spindle or quill travel. So as we turn this down, oh, we've got this stop set over here still. So let's move this all the way up. And over here, now if we come back, we've got about a 6-inch spindle or quill travel that we could drill through there. So we don't want to be too high above the workpiece because we need to make it all the way through this piece. We want to make sure that as we line it up that we're not scraping the workpiece with the bit. So that looks pretty good there for our height. So now if we look like we're going to hit that black box down there, right? If we accidentally go through our workpiece, we're not going to hit the steel table. Now we can come back over to the left side and lock that handle so that the table does not move. So now we've got this fixture or jig here that needs to be clamped down. If we don't clamp it, it's going to move and vibrate around, and it's going to make us not have a straight hole or a uniform hole. It's going to make it reamed out in some spots. So we're going to take our twist clamp and clamp this jig to the table. So I'm going to take my clamp and just get it in here so my jig is clamped down. Now I'm kind of getting these jaws at an angle here, so you might have to manipulate things around. Maybe your clamp's going to go over here on this time. Or, like we talked about before, the excess material, because this board is longer one direction, maybe this whole thing just needs to be turned around. So set this up accordingly so your extra material is off to the correct side, and then you should have support. When we clamp it, we do want it to be nice and tight along the table still. Now when you start drilling, I like to keep my hand on the jig. That way, again, I can feel if things are moving or vibrating loose. So I would turn it on, I would start drilling. On something this big, you're going to clean the flute out several times. If you try to go at this at one shot, this is going to get super hot. Typically, it starts squeaking in the hole as you're drilling, indicating that the bit is hot, and you're going to likely crack your piece of material because of all the extra heat and friction. So that's how you would set that up for drilling out your pen blanks. If we're going to be drilling some smaller pieces, we're going to need to use a couple clamps to hold our work pieces. So our first clamp here is going to hold our workpiece parallel to the table. And then what we can do is come in with our other clamp and clamp the first clamp to the table. This way we're securing it so it doesn't move, and our hands do not have to be within that 4-inch margin of safety. I can hold on to my workpiece way back here or over here if it's on that side. This would allow you then to come in and make your cuts. When I'm getting ready to drill, okay, we usually have one hand on the workpiece and the other hand is operating our drive wheel here. So what I like to do, rather than grab the nearest handle, is maybe grab one that's back further or up higher, because then you can get more turn. Okay, because usually you just have one hand to operate this. So you would grab it and you would just have to spin it around continuously. Okay, you wouldn't do this two-handed because your other hand's down, making sure the workpiece doesn't move. Remember, you have it clamped, but you're just making sure it doesn't move by feeling it. So you really wouldn't two-hand this over here. You wouldn't go one hand every other direction. You're going to use one hand to grab one of the knobs, spin it around, and one continuous flow with that. So this particular unit is an 18-inch drill press, and what that means for us is that we could drill into an 18-inch wide board and still get into the center of that. So that would mean from the distance from the center of the bit to the post in the back is 9 inches. That would allow an 18-inch board to be drilled and be able to get in the center. So this is an 18-inch drill press, and that is how it is referred to, an 18-inch drill press, because of the size there. Now there is some other parameters that define a drill press, and one is going to be the horsepower that runs it. The other is going to be the quill or spindle travel, and that's how far you can actually drill into something. Okay, the bigger it is, the less you have to adjust your table and make different sizes. So when we bought this, we looked for one that had a long quill travel so that we could drill into our pen parts and make it all the way through without having to adjust it. This is also a floor unit, and so the table will lower down a lot lower than a benchtop unit. A benchtop unit, you usually only have a couple inches of travel on the table surface. The floor models can actually be dropped down a lot further. The table could swing out of the way, and you could set your workpiece right down on that steel surface at the bottom, allowing for really tall pieces to be drilled. If you have any questions about using the drill press, please talk to your instructor and make sure you get those questions answered. We want you to feel safe and comfortable using this machine and have the adequate knowledge to use it safely. So again, if you have any questions with this machine or any other machine in the shop, please talk to your instructor. If you have any questions with regards to this machine or any other machine in the shop, please talk to your instructor so we can get those questions answered and you will be comfortable and have the knowledge to use this machine safely.